Good afternoon, everybody. I'm going to speak about a disease that is not common here. So I work doing my PhD for the group of pathogen and disease of University of Valladolid. And I'm going to speak here about our work with Griffonetia parasitica, the canker of the chestnut trees, and how we treat it. I'm going to try to explain the work that we are done and how we assess the treatment in the field. First of all, to speak a little bit about the canker, the Griffonetia parasitica is a fungus that comes from East Asia and spread over the world. And the fungus is in America, is in Europe, is all over places that are chestnut trees. It's spread by spores, by wind, rain, or insects, and you can treat it with a virus that causes hypovirulence in the fungus. Well, first of all, this is the scheme that I'm going to follow. The sampling that we perform in Cantabria is marked here, the different places and the different samples that we took. And once that you have the sampling done, you have to go to the laboratory to do the isolation in individual plates. With these plates, you have to know the compatibility group of each fungus that you have, because in Griffonetia parasitica, you have to know this, because then if you want to pass the virus between these fungus, it's able to do it only in the same group of compatibility. Then we look for virus in the field. Then we transfer the virus from the fungus that we collect from the field to the other fungus that we want to treat in the field, and then we inoculate again this fungus with the virus in the field. First of all, the isolation, we go to the field, we take the samples. This part of the tree with the branches is better, or with the trunk. We took from the part that are alive of the tree and have the disease. We go to the laboratory, we put a wet chamber, we took an spore that germinates in the top of the bark, and we do a plate isolate. With this plate isolation, we determine the vegetative compatibility groups that I explained a little bit before. The two fungi that are from the same vegetative compatibility group can fuse and change the genetic material. We have here an example. These ones are from the same compatibility group, and these are from the different ones, and these are from the different ones. We can see that there are not mixes. Well, the compatibility group, to determine which is the compatibility group, we have to do DNA extraction, first of all. Then we have to amplify the cycloside and determine this different compatibility with a PCR. For each fungus, we have to do 6 different PCRs because you need to determine 6 different peaks. With this, we get a code, a numerical code. Each study, this is known, and you can go to the bibliography, and there are papers where related this code with the compatibility group. In this case, is EU1. Once you have your compatibility group, you need to get a virus from the field with the same compatibility group that you have in the field and you want to treat. You have to go from healed cankers that are in the field, take a small piece as we did before with the virulent ones, and do an RNA extraction. With this RNA extraction, you get a double strain of the DNA with cDNA synthesis, and then you amplify a specific region of the virus and get if you have virus or not inside of this fungus. In Griffonetia parasitica, you can also see morphological difference between one strain that have the virus and the other that don't have. Like here, you can see that it's orange one and other is white. This is because you have spores on the top, and that one reduced the production of spores and the virulence of the strain. We were able to get 2 different strains from the field with virus. That is one of the results. We get 2 strains with the hypovirus 1, and we get nearly 200 samples from the field. Most part of them in Cantabria were EU1, and then we have 3 different compatibility groups close to Basque Country. That's really good because the most part of the Crifonitia parasitica disease that we have in the field are from the same compatibility group, and we can go there with the virus that we get and try to find a solution with this virus. The future work that we have to perform is transfer the virus in the laboratory. We are not done it yet. It's like this. You put 1 plate with both strains, one with the virus and one with no virus. The virus pass to the other strain. You get the strain that you get from the field, and the same strain now with the virus you put in the tree. With this system, you make holes around of the canker, and then you put inside the fungus. The fungus is going to grow. It's going to get to the other IFA and get a fusion with the other IFA and transfer the virus. And this will get the canker healed. And now the main thing that we want to do now is try to increase the spread of the hypovirus strains, the virus in the field. We need something to do that increase the spread of the virus. As I told you before, the virus get that the fungus sporulate less, and the dispersion of the virus get reduced. And that's all. Thank you.